Here's a video on graphing a linear system of inequalities. So I have two different problems here. I have number one, which is two inequalities that are both in slope-intercept form. So I'm going to use this pink for the top equation and blue for the bottom equation. The top equation has a slope of -4 and a y-intercept of +1. So I'm going to start at my +1. And my slope of -4, I can either go down 4, 1, 2, 3, 4, and right 1, put a point here at 1, -3. Or I can go up 4, 1, 2, 3, 4, and back 1, and put a point at -1, 5. The difference between this and a regular line, or one of the things, is that we have an inequality symbol here, and there's no equals. So you should, at this point, know that this is going to be a dotted line. So it should look like that. When I look at the other equation, I'm not going to do the shading quite yet. The other equation, the slope is -1, and the y-intercept is -2. Starting at -2, and with the slope of -1, which means down 1, right 1, down 1, right 1. So this basic staircase gets me to all my points. So that set of points would be this line, and this one has the equal sign, so I'm going to draw a solid line through those points. So it kind of looks like that. So those are the equation parts. Now, I need to work on the shading. So I like to use the point 0, 0 whenever possible, right here. And if I look at that point and I plug it into my inequalities, the top inequality would look like this: 0 in for the y, -4 times 0 plus 1, 0 is less than 1 is true. So for the top inequality, I would shade towards 0, 0, because 0, 0 was true. So it's this whole region here gets shaded. In this case, in the pink. For the other equation, let's look at this one. If I plugged in 0, I get 0 is less than or equal to negative. I'll change the sign to 0, is not going to matter. So I end up getting 0 is less than or equal to -2. That's false. So for this line, this point is false, which means I'm going to shade on this side. And I'll use a light blue highlighter here for that. So on this side, I'm shading all of this. And you can see that there is some overlap. First of all, I'm going to make the boundaries of this double shaded region a little bit more bold so that it really stands out. So that now bolded area, that line, is the boundary of my region. And then to really emphasize that this shaded region here is the actual solution set, I'm going to really go over that with the highlighter. So this darker double shaded region is the solution. And a similar process for the other problem. The only major difference is how we're going to get the information from the problem. So I'll use red for the top. And on this one, I'm going to have an x-intercept of -3 and a y-intercept of +3. And since there's an equal sign, it's going to be a solid line. It looks like a slope of +1, so it looks like this. And then I'll use a blue line for the bottom equation. Slope is -3/2. Y-intercept is -2. So starting at -2, I'm going to go down 3, right 2. I'm going to go up 3, left 2. And it is a dotted line. So that's the line part. And if I were to test for 0, 0, so in the first equation, 0 minus 0 is greater than or equal to negative 3. 0 is greater than negative 3 is true. So I'm going to shade, this is true to the red line, so I'm going to shade below the red line. And then 3 times 0 plus 2 times 0 is greater than negative 4. That ends up being 0 is greater than negative 4. That is false. So for the blue line, this point is false, so I'm going to shade on this side. Where is their double shading? Well, here's the boundary. Dotted line on this piece. Solid line on this piece. And the double shaded region is over here. So you don't need highlighters. You can actually just do it with colored pencils, or even just the same color and just make it darker. And that is